Hello everyone, so this is a video about our fabrication process of turbine blade. Our group consists of 4 members. The first one we have the group leader, Daim Hakim, and then we have Muhammad Irfan Anik. We also have Muhammad Nabil, and the last one we have Danish Aiman. So in this video, we are going to explain about the detail of the fabrication process of the turbine blade. To begin fabrication of our turbine blade, we start with measuring process. The objective is to cut the raw material into predefined shapes and sizes based on the technical drawings. First, we use a vernier caliper and steel ruler to measure the raw material according to the required dimensions. Then, we double check all measurements to ensure accuracy and prevent errors during cutting. Once confirmed, we proceed to the marking stage. A marker or scriber is used to clearly mark the cutting lines on the material surface. For any holes, we use a center punch to make indentations for precise drilling later. This process ensures the material is properly prepared for the next step, which is cutting. The next step in our turbine blade fabrication is cutting process. The objective here is simple: to cut the material into the needed shape and size based on our markings. We use a handsaw for manual cutting and a file for smoothing the edge after the cut. Before starting, we took proper safety measures like wearing gloves and safety goggles and clamping the material firmly to avoid slipping. The procedure begins by following the marking lines carefully, cutting with the handsaw using steady and controlled strokes. After cutting, we use a file to remove sharp edges and refine the shape. One problem we faced during this process was blade deviation, where there was slightly drifted away from the line, especially during longer cuts. To fix this, we slowed down our cutting speed, check our alignment regularly, and refine the edges to correct the shape. This step is crucial to ensure the part matches the required dimensions before moving to the next step.
Next is lathe. On lathe machine, we do a turning process by securing a cylindrical hook piece, minimum 20 mm diameter and 60 mm length, in the lathe 3-jaw chuck. Start with a facing turning tool to smooth the front surface of the material. Then, use a side turning tool to reduce the front section to a 16 mm diameter or 16 mm in length. Switch to a finishing turning tool to refine the surface and achieve accurate dimensions. Next, move to the middle section and use the facing tool again to shape the 20 mm diameter portion to a length of 18 mm, followed by finishing cuts. For the final section, use the same tools to reduce the rear 16 mm to 16 mm diameter. Throughout the process, verify measurements with a vernier caliper. Maintain proper speed and fit rates and finish by using a parting tool or chamfer tool if needed for edge cleanup and part separation. On the next workpieces in the turning process, we cut the two workpieces into a circle shape. We begin by securing a cylindrical workpieces with a minimum outer diameter slightly larger than 55 mm diameter based on 27.5 radius. Mount the workpieces on the lathe using a 3-jaw chuck, ensuring it is properly centered. Start by using a facing tool to clean and flatten the front surface. Then, with an external turning tool, reduce the outer diameter to 55 mm diameter, double the 27.5 radius after turning, with their center position on a pitched circle radius of 18 mm. Lastly, they were all sharp edges and verify dimensions with a caliper or gauge before final inspection. Next is milling. The given part using a milling machine in an M4 4mm anvil. Begin by securing a raw workpiece slightly larger than the final. Face mill the top and bottom surfaces to achieve the final height of 17mm. Next, mill one end flat and cut the overall length to 21mm. Then, create a 3mm wide slot that is 5mm deep and extend 6mm into the length, starting 50mm from the initial edge. After that, mill the back shoulder cut measuring 5mm wide and 5mm deep at the rightmost end of the part. Use multiple shallow passes for precision and to avoid the tool overload. Finally, deburr all edges and verify all dimensions using measuring tools like calipers before cleaning the part for completion.
Now, we move on to the drilling process, one of the key machining steps in fabricating our turbine blade components. In this step, we use a bench drill press to create precise holes in the plates, specifically part 2 and part 3, as shown in our technical drawings. These holes are essential for the alignment and assembly of the turbine blade. First, we carefully mark the hole positions using a center punch to ensure accuracy and prevent the drill bit from slipping. The workpiece was then clamped securely onto the drill table to avoid any movement during the operation. We selected the appropriate drill bit size, including 6mm and 10mm bits, based on the drawing specification. To reduce tool wear and heat build-up, we occasionally applied cutting oil during the process. As a safety measure, all members involved wore safety goggles, gloves, and made sure that no loose clothing were near the rotating parts. We also avoided touching the metal chips directly to prevent burns or cuts. One issue we encountered was bit dulling, which caused rough hole edges. To solve this, we replace it with a sharper high-speed steel bit and slow the feed rate to maintain accuracy. In the end, the drilling process was successfully completed and all parts were prepared for the next fabrication step.
Next, we will move to grinding process. Before we do the welding process, our group do the bench grinding process first to get fine structure for each part. So, what is bench grinding? Bench grinding is a machining process using a rotating abrasive wheel to remove material. Next, what safety equipment we must wear before do the bench grinding process? First, we need safety goggles to prevent any foreign object from entering our eyes. We also need heat-resistant gloves to protect our hands from heat during the process. Also, other equipment like protective clothes and safety boots. To grind safely and effectively, hold the workpiece with both hands. Use the tool rest to support the material. Keep the workpiece moving side to side to avoid overheating, and always apply moderate, steady pressure. Never force it. Here a step-by-step look at the grinding process. First, inspect the grinder and the grinding wheel for any damage. Adjust the tool rest close to the wheel, about 2 to 3 mm. Next, wear safety gear and switch on the machine. Next, gently press the material against the wheel and move it side to side. Periodically cool the workpiece in water to prevent heat damage. Once done, inspect the finish and shut off the grinder safely. Bench grinding can sometimes lead to common problems such as overheating the material, uneven grinding due to staying in one spot too long, and vibration from an unbalanced wheel. To avoid these problems, we use the correct grinding wheel for material. Dress the wheel regularly to keep it flat and clean. Avoid side pressure, always grind on the wheel face. We also keep the tool rest close and stable, and remember to cool the workpiece frequently. To improve grinding efficiency and safety, Your ATM can add a spark shield or a better lighting around the workstation. Use angle guides on two rests for precision. Upgrade to a variable speed grinder for better control. Or install a coolant tray for faster quenching during grinding. So this is how our group carries out this process. Before Nabil carries out the process, he wears gloves and goggles. After that, he holds the workpiece and grinds side to side, and we get a good finishing result. Next, we will move to welding process. So I just explained about sheet metal arch welding because in this welding process we just use the SMAL. So what is SMAL? SMAL stands for sheet metal arch welding, also called stick welding. It uses a metal rod called an electrode that melts and joins the metal pieces. The rod is covered with a special coating called flux. When it burns, the flux creates gas and slag to protect the weld from air, making the joint strong and clean. Before performing any welding operation, safety is the top priority. We wear a welding helmet with the correct shade to protect our eyes and face. We also use leather gloves, apron, and safety boots. Proper technique is crucial for quality welds. Maintain a short arc length about equal to the electrode diameter. We hold the electrode at 10 to 15 degree angle from vertical, and we also keep a steady travel speed and consistent hand motion. We also use wave pattern depend on the weld joint and weld position. So how we do this welding process? First, we clean the metal surface to remove rust and paint. Second, we select the correct electrode based on the base material. Third, we set the welding machine to the correct current and polarity. Next, we strike the arch by scratching or tapping the electrode. Next, we weld along the joint, keeping a steady pace and proper angle. 6. We let the weld cool and then remove the slag using a chipping hammer and wire brush. Lastly, we inspect the weld visually for any defects. After finish do the welding process, we found out that we face problems like porosity and undercut. We also face problems like difficulty striking the arch due to wrong setting or electrode storage. After face this problem, we found out that to prevent this problem from happen again, we can use dry electrode stored in a raw oven, clean the metal thoroughly before welding, use appropriate amperage and polarity, and remove slag completely before starting another pass. Lastly, for the improvement, your ATM can provide the low hydrogen electrodes like E7018 for critical welds, and can apply quality inspection methods like dye penetrant or ultrasonic testing, and can upgrade our PE. Before we start the welding process on our workpiece, Nabil tests the electrode that will be used on the iron provided by UITM to ensure the electrodes works properly. After starting, Nabil used wave patterns depending on the weld joint and position, and we get a good result of welding process.
Next is the finishing process. For this project, we use a hand grinding machine instead of sandblasting. The main purpose is to smooth out the surface of the turbine blade, especially to remove any weld bits, sharp edges, and rough spot left during fabrication. First, we secure the blade properly. Then, use an angle grinder to gently